Now we come to the Bragg edge fitting step. The first thing to do is load the normalized images. Once loaded, they will appear in the top left window. You can use the slider to scroll through the images and check that they have loaded correctly. Click the Auto Adjust button to automatically optimize the brightness and contrast for better visualization. And next, set the flight path using the designated button. By default, it's set to 56.4 meters, which is the commonly used flight path on iMac. Then set the time delay, which shifts the entire wavelength span. If you are unsure whether a time delay was used in your experiment, it's best to ask the scientist who helped you during the beam time. To inspect a spectrum, set coordinates and click the Pick button to define a box on the image. The wavelength spectrum will appear on the right-hand side of the window, and a yellow box will show the area used to extract it. You can export this spectrum as a CSV file by clicking the Export button. You can also adjust the wavelength span to focus on the Bragg edges you are interested in. If you know the material phase, you can select it from the drop-down menu. If you are unsure or don't want to specify it, simply choose Unknown Phase. In this example, the material is ferritic iron, so we will select FeBCC. Once a phase is selected, the edge table is automatically populated. This table shows each HKL, the theoretical Bragg edge position, and the wavelength range for region 1, 2, and 3. Region 1 is the pre-edge plateau on the left, region 2 is the post-edge plateau on the right, and region 3 covers the entire edge span. These default ranges offer a reasonable starting point, but you can manually adjust them for better fitting accuracy. You will also see parameters S, T, and eta, which define the edge's shape and width. You can also choose to fix these parameters during fitting using the check boxes provided. To fit an edge, select it in the table. The corresponding spectral regions will be plotted on the canvas. Once you are happy with the data quality and region definitions, you can start the fitting. NEAT provides two fitting modes: Fit Edge, which fits each edge independently, and Fit Pattern, which fits all edges with a shared lattice parameter, similar to full pattern fitting in diffraction analysis. Click Fit Edge to start. The fitted curve will appear on the plot, and the S, T, eta values will update in the table. Results also appear in the message window below, so you can review and decide if you are happy with the fitting. If the results aren't satisfactory, try using a different edge, a larger box, or adjust the regions until you get a good fit. Once you are happy with a single fit, you can proceed to batch fitting to create a map. Start by setting the box size, which should match the size used in your initial fitting. Then set the step size, which determines how many pixels the box will skip when moving in X and Y. You can check the interpolation box to fill in skipped pixels in the result using interpolation. Next, define the region of interest and click the ROI button. The ROI will appear as a yellow box on the image. Before launching the batch fitting, choose whether to fix S, T, and eta using the values from your earlier fit, or leave them free. When ready, click Batch Edges to begin. A red box will move across the ROI as the fitting progresses. For pattern fitting, the procedure is the same as for edge fitting. After the batch fitting completes, the results, both interpolated and non-interpolated, will be saved as CSV files, which you can load in the Post-Processing tab. A useful feature in it is the ability to check the fitting at specific locations. Just enter the X, Y coordinates into the box and click Fit Check. The fitting results at this point will pop up in new windows, helping you confirm the quality across the ROI. You can also save the fitting plots and data for future use. If you select Unknown Phase, the edge table will be blank. You can manually enter the D-spacing of the edge you want to fit. Set the wavelength regions and define S, T, and eta yourself. Since there's no crystallographic information, pattern fitting is not available, but the rest of the process remains the same. Now the Bragg edge fitting is finished. In the next video, we will show you how to view the results in the Post-Processing tab.